Hi everyone, we're going to graph the function, this polynomial function, and find all of its x and y intercepts. So the first thing I'm going to do is to factor this, and I want to see if I can factor by grouping, and I can, so I'm going to just change this to y equals, and I'm going to pull out, let's see how I'm going to do this. I'm going to pull out an x squared here, and I'm going to get 2x minus 3. And here I'm going to pull out a 4, and I get x minus 3. Remember, when you're factoring by grouping, if you have a negative here, you're going to have to change this to negative, because negative 4 times negative 3 is positive 12. So now that these two are the same, I can put this together as x squared. I'm pulling these two together. X squared minus 4, and it should be a 2, sorry. And since these are the same, and then times 2x minus 3. All right, these two are the same. And when you have those the same like that, you can factor by grouping. Now I can further factor this more, and get x minus 2 times x plus 2. That's the difference of squares. And then I still have my 2x minus 3. Now, to find the x-intercepts, we let y be 0. So I'm going to let y be 0. And if I set each piece of this to 0, so if I just look at this first piece, x minus 2 equals 0, so x is 2. And here, x plus 2 is 0, so x would be negative 2. And when I set this to 0, this would be x equals 3/2. Okay? So you're just, setting this to 0 and solving for x. All right. Now, you should really write this as 2 comma 0, negative 2 comma 0, and 3/2 comma 0. Those are your x-intercepts. Your y-intercept is when x is 0. So all I'm going to do is take my equation here. Whoops. All right. Take this equation here, right there, and everywhere there's a x, I'm going to put a 0, because when x is 0, we want to know what, we want to know what y is. This would equal your y. This cancels out, this cancels out, this cancels out. So your y-intercept is 12. And basically all you had to do was just pull it out right here. So there's your intercepts. I do know that my degree is 3. So my end behavior, we're going to be starting in quadrant 3 and ending in quadrant 1, because it has the power function as y equals x cubed. So that's what I'm going to do. I'm going to graph my x-intercepts and my y-intercept, and then graph it. So I have, we have x's 2 and negative 2, and I just tend to put x's here. And then we also have 1.5, which is right about here. All right, my y-intercept is 12, so I'm just going to call this 12 up here. I know I'm starting in quadrant 3, and the multiplicity of this is, all of the multiplicities are 1, so it crosses the graph. And there's your graph of f of x. Okay? And you can also use a calculator on this and check it as well. This should have actually went through this point here. It's really hard to graph on these iPads here, so it should have went more like that. Okay? So anyway, there it is. Now the next one, we have this equation, and we have to do more. We have to graph it, determine the domain and range. We already know how to find the x and y intercepts, describe its its end behavior, and estimate its turning points. Well, since our degree is 4, my turning points is going to be n minus 1. So degree is 4. So 4 minus 1 is 3. So it can have at most 3 turning points, but we're going to graph this and see. So the first thing I have to do is factor, and I'm going to go ahead and pull out the negative first. Then I'm going to factor. So I'm going to get x, they're both negative. These are squares. And we have, it's 9 and 4. Is it 9 and 4? This is supposed to be 13. So we can do 9 and 4. And I can further factor, because these are the difference of squares, x minus 3 times x plus 3. And this is x minus 2 times x plus 2. So my x-intercepts, and I'll put them over here, when I set y to 0, is going to be 3, negative 3, comma 0, 2, comma 0, and negative 2, comma 0. My y-intercept is just going to be this right here. I look at my original. So when x is 0, y is negative 36. And you can just write them like this, because by definition, that would be your x-intercept, and that would be your y. All right? We estimate the turning points as 3, domain and range. Well, we know that this looks like y equals negative x squared. So we know it's going to start in quadrant 3 and end in quadrant 4, because this is our power function for that. So we'll describe the end behavior after we graph it. So let's graph it, and then we'll talk about the domain and range. All right, so I went ahead and kind of scaled this. On my y-axis, I went by 4s here, and on my x-axis, I went by 1s. So I'm going to graph my intercepts, and I forgot what they were. 3, 2, and 2. Okay, so we have 3, negative 3, and 2, negative 2, and 2. My y-intercept is negative 36. Now I know I start in quadrant 3. I'm going to go up, come back down, and hit all these main points. All right, we're not really worried about the min and max. So how many turning points did we have? It turned here, here, and here. So we did have 3 turning points. Okay. My domain can be all real numbers. So I don't know how you want to write that, but your domain is all real numbers. Okay. And your range, we don't know the min and max, so you have to use that with the calculator and find how high the min and max goes on your range. And then for the end behavior, what we're looking at is this area in here. Okay? So you put infinity here and here, negative infinity here, negative infinity here. So as x, right in here, as x approaches negative infinity here, y is approaching negative infinity. So as so y goes to negative infinity, as x approaches in negative infinity. Now on this side, as x approaches infinity, we're looking at this part, y is still going down. So y approaches negative infinity as x approaches infinity. That's your end behavior, if you have to write it this way. Okay? The next video is just going to be about using synthetic division and finding zeros and rational zeros. Thank you and have a nice day.